cratering we see on our moon today is from this period. It may be possible that swapping orbits with Uranus is how Neptune got its moon. Today, the epoch of planetary migration appears to be over. The solar system seems stable, but what does the future hold? Computer simulations reveal what may be the greatest threat to the solar system in over 4 billion years. It comes from a very special relationship between Jupiter and Mercury. Mercury's orbit is slowly perturbed, thanks to a subtle but constant gravitational nudge from Jupiter. A new resonance, the same planet of Jupiter, but same from the solar system, is forming between Jupiter and Mercury. In 2009, computer models for the solar system were running 2,500 times.
They plug in the positions and the orbits of all the planets in the solar system on the computer, and they just let it run through time, through millions of years, hundreds of millions of years, billions of years, find out whether or not these orbits are stable. Change the location of one planet, say 1 million, and you find that that change will give completely different predictions about where everything is going to be millions of years in the future.
To see how quickly and easily things can change, we have to go back to our measurements.
All I have to do is stop this platform with a movie so it cannot spin freely. Now, there's no way for the measurements to influence each other. They're good measurements, but they're not perfect. They can't be going at exactly the same thing. They're just going to fall apart because they have no way of forcing the others to go to regular.
The same applies to habits. Any small change can affect the brain or restore it.
Now that the platform is free to swing again, it can again transfer energy and sync them up just like we saw the first time.
Scientists want to know the final consequences of a destabilized planetarium. In one case, Mercury leaves the solar system. The rest of its gravitational pull disrupts the balance between things and Earth. Earth and Venus slow orbits. The superheated interstellar Venus oceans rise, the land cools, and the air thins. Even the remains of the ancient visitor begin to cool off. Venus becomes like Earth, but the reverse happens to the Earth. As Earth settles into Venus's orbit, temperature rises. The Earth becomes more glaciers melt. Oceans cool. The sun looms larger in the sky, only to be obscured by a thickening cloud cover. Suffering will be great. The entire 4 billion years of life is cooked in a matter of days.
Friendly Molotov.
Sterilized, uninhabitable, and quiet. There is another possibility, equally dark and apocalyptic. Our runaway Mercury is deflected by the gravity of Venus and falls toward the Earth. opening act of our solar system. The equilibrium of the energy is over. If this scenario is Mercury crashes into the Earth, just as Theia did 4 billion
Friendly
years ago.
Molotov.
The question is, could it happen today? Or is it a fate far away in the future? At a time when mankind itself is but a distant memory. The masses, sizes, speeds of all of the atoms. On its own, we may never see such a phenomenon. But among the billions of stars in our galaxy, how many worlds are on the map? How many will stars fit?
We do have our own extremes here on Earth, but they pale in comparison to the fastest, dustiest, wettest, and most brutal alien storms.
Mission accomplished.
The sun drives our life, and sometimes drives it wild. When hot and cold collide in the atmosphere, watch out. This is true locally and globally. But storms on other planets are bigger, badder, and stranger than their counterparts on Earth. Why is that? Because of the sun? If not, what else fuels their fury? The basic laws of nature, the rules of being, are pretty much the same wherever you go in the solar system. Every planet has its own way of playing the game. Right now on Mars, the entire planet is being covered in dust. Blocks 99% of the sun's rays from reaching the planet's surface. A smaller but still massive storms churning dust. It takes months for Martian skies to clear.
Mars is just the most dramatic way in some places. It's very rare in the sort of weather event that can take out the whole planet.
So, if the basic rules of hot and cold are on Mars, why is the weather so different from Earth? For one thing, Mars is half the size of Earth. It's also 50% further from the sun, so it's much colder. The average temperature on Mars is minus 80 degrees. That's almost 100 degrees colder than Earth. And composed mostly of carbon dioxide. But perhaps the most important difference is this. Mars is a global desert.
What would Earth be like without water? Well, we'd probably no liquid water at the surface of Mars, and there's very little water in the atmosphere, and so there's nothing to sort of keep the dust.
On Earth, dust storms are localized and short-lived.
The reason for that difference in scale is that the generating their own weather on Mars, whereas on the Earth, they're slave to the what's going on around them.
In other words, on Earth, the global weather system
Reloading.
dust storms. On Mars, The storms create a global weather system. Astronomers have always been able to see big Martian dust storms easily with Earth-based telescopes. But what they couldn't see was what caused them. That would require a trip to Mars itself. In 2003, NASA landed 2 rovers called Spirit and Opportunity on the Martian surface. Their mission? To learn more about the geology of the red planet. NASA engineers always assumed that as these 2 vehicles roamed the Martian surface, dust would build up on their solar
If you have a lot of dust that's falling down out of the atmosphere and coating the panels, pretty soon you're not getting much sun to the silicon. And in fact, we thought that was what was going to kill the rover Spirit and Opportunity.
Only it never happened. The rovers didn't die as expected. As dust built up on the panels, somehow something would clean them off. But how could this be? NASA engineers were baffled until the rovers themselves saw the culprit. Martian dust devils.
It turns out that dust devils were sort of our white knight. They came along and cleaned off the solar panels just at the time when we were expecting to start having some problems.
We've taken the lead.
Photos that actually show dust devils moving across the Martian atmosphere and go through soldiers moving out there in distance.
A dust devil is really an extremely fast rising hot air convection.
And that's how they went today. And things like this one from the water going down and rain. So this is air that aspires up into the cold part of the atmosphere.
Whenever warmer air, which is less dense, rises up through cooler air, which is more dense, it rotates as it swirls upwards.